Hey, what's happening, guys? Avery Looper here in the lab at M2C Racing. We got a really fun one for you today. How did they do that? Episode 12.1. It's going to be about making the Talion Front Towers for the new Talion 1.7. We're going to come all the way along with this journey. We're going to have some fun, and I got a special surprise for you. We're going to do some FPV machining. So come on and let's do this. Here's what we're making right here, boys. Look how sexy that is. Oh yeah. Beefy. Let's have some fun. I want to give a big shout out to all my team members. Thanks so much for the support, guys. It's been a fun ride and it's going to get even better. You can also join the team at our YouTube channel. Come on down and check us out. So Kenny turned me onto this stuff and over at DRC because he got one of these scanners. Now this is supposed to, he said it works, so I'll sign off on it if Kenny will. We're going to try it. Hopefully I'm not going to regret doing it inside, because it will save me some time, especially when it's raining. I don't know. We're going to try it. Now this stuff here is Revo Point, and it's supposed to disappear. So I do want to say that this spray is growing on me. I'm starting to like it because it's pretty cool. I can spray it here in the office. It's ready to go pretty quick here. So I am starting to like it. I will say that. Hey, good morning, guys. It's Friday morning, and we're here at the shop, and I'm outside because it's so doggone beautiful that I just wanted to be outside and enjoy this beauty. God's green earth. I'm going to tell you what, man. It is just a beautiful day. But I'm going to go inside and get to work on these Talion parts because I got to keep them coming for you. So let's get in there and get to work. Okay, guys. We're back in the shop. I wish we could be outside, but we can't. I probably should paint this stuff outside. I don't know what this is, kind of aerosol stuff. So Kenny turned me onto this stuff and over at DRC because he got one of these scanners. Now this is supposed to, he said it works, so I'll sign off on it if Kenny will. We're going to try it. Hopefully I'm not going to regret doing it inside, because it will save me some time, especially when it's raining. I don't know. We're going to try it. Now this stuff here is Revo Point, and it's supposed to disappear. So let's get up on the stand, and because we got these Talion parts we got to work on. I got to get this stuff done, and we got a little special surprise up here we got to work on too. I'm going to take that battery tray off right there, and I'm going to fix these guys' goofy battery tray. I'm going to make something so that it'll cover this thing. Me and Brett came up with something the other day. So I do want to say that this spray is growing on me. I'm starting to like it because it's pretty cool. I can spray it here in the office. It's ready to go pretty quick here. So I am starting to like it. I will say that. So I didn't spend a bunch of time documenting this one because all I did was the same thing I did on the other one. Just a little less fiddling. I'm going to go ahead and print one of these. As you can see, I beefed it up. Let's turn off as you can see, I beefed up the sides and the hinge pins. It's got those hinge pins with the big heads. So I had to make reliefs for those. So I beefed up the side around that. And we're using button head screws for the, the body posts. I'm not a fan, but I had to keep the same height because I know the body's already hitting here, so I didn't increase the height. As you can see, I'm still pretty related to the scan. You can see it poking through a little bit there. I did beef it up in the center, and I beefed it up in the thickness, of course, because now it'll be a 9mm. But yeah, I'm gonna print one out and we'll fit it up to the car, and I'm liking it. I'm thinking it's gonna be real nice. Let's get one printed.
Look at that sexy little fatty. Let's get her drilled out and put on the truck.
Good morning, guys. We're here with the final piece that we're designing on the Talion right now. I still got to program everything, but let's drill this sucker out. Let's put it on and see what happens. Here's what I came up with versus stock. So this uses the big hinge pins like this. So in previous versions we made it 5mm up to here, But we're fixing to find out, because I think it's not going to hurt a thing to have the entire head of this thing recessed. And the head on mine is smaller, and you probably want to use those instead, because they actually have a so let's fit this sucker up. You can see the thickness too. So let's fit this sucker up and see what she's gonna do. So what should we do? Because what I'm looking at is the head of this screw. I made it to be countersunk so that I can make this front tower as beefy as possible. You know, because it's going to take all the impact in a front hit, and it's going to take all the impact off tire hits too. So, because we want the arm to fail, that's our goal in designing a tower. You want the arm to fail because these are cheap and easy to replace. So, what we're gonna do? Yeah, because you see, I guess I'm gonna have to go back in here and do a little cutout right there so that you can get a screwdriver under this. That would be the only way I could see it working. So let's go do it. Okay. Pretty sure this is going to be the final revision right here. Check that out. See how I put a little tab for you to get a screwdriver under and pop your hinge pin out? I missed that on the original design. This one's looking pretty nice. Pretty nice. So, oh, I didn't take that one off yet. Taking more time, because the thing about the 3D printer is that you get kind of spoiled. Oh, I'll just print one, it'll be done in a half hour, you know? And you get kind of spoiled with it. So you're able to move faster and on to the next part. Print this one, fit it up, do all that, right? And you can get more done faster. So, that's the great part about a 3D printer. These go like that. Just thing flopping around. I know you probably can't see what I'm doing. Ooh, good fit. Bam! Oh, that looks clean too. I'll show you that in a second. That's gonna look clean right there. Yeah, and you got plenty of room to get something under there. Just, nobody even commented on my top view. Oh, I didn't post that top view video yet. That's probably why nobody commented on it. Okay, that makes sense, right? Okay, so we're gonna get. Okay, yeah, that looks. I like that. I like that a lot. Let me see if I remember what happened here on. I think on the. Oh, let's put the body mounts on first. What do we got? We got button heads on the body mounts. Y'all know I don't like those. It's kind of a waste of space to me. I don't know how the tower's hitting the body on that. I reckon we'll find out in a minute. I seen some posts complaining about that, so did I put that on the wrong side? These are labeled, these body posts are labeled right and left now. I don't know, how you lose stuff on such a small workbench? Y'all already know, because y'all doing it too. Y'all could probably see it on the video. But I know this happens to y'all, so you can laugh at me if you want. Ain't gonna be the last time it happens. Oh dear. put it in here. No. There it is. I don't know how it ended up back there, but it did. Oh, this has got one long screw and one short screw. Let's give me the short screw. So I'm not going to bother. See, that's really nice. They put a nut in there. Oh, this is the left side of the car. Okay, yeah, it's fine. It's fine. Okay, so let's put this back up. Let's put this on. I'm not seeing how. Back in there. We're gonna have to. I don't see how. I guess I should show you guys that. Oh yeah, I do see how. No, you know what? That wasn't. Oh, you see, I can make that bigger, fellas. I can make that bigger. I'm gonna try to get you guys in here. Show you this. There's room up there. Okay, so what I'm gonna do, guys, is I'm gonna post this video. Can you guys see up in there? There you go. Okay, so I'm gonna post this video, and then I'm gonna, if you guys think I should, I can't do anything with the back, but I can make the front thicker like I did on the back. I can't do any more on the back, so I'm gonna post this video real quick. And I'm gonna see if you guys think that I should raise this tower up. I should have put these on first. I can raise the top of this tower. I could probably come up a 1/4 inch, and before I touch the body, I could probably raise this entire line up a 1/4 inch and kind of fade off there like I did in the back. So I'm gonna post this video. You guys tell me if you think I should leave it like this, because I think it's really beefy right now. But I could add probably 5 millimeters, maybe even a 1/4 inch, 6 millimeters to a 1/4 inch up on the top of this thing. Just come straight up and arc like that. I'm gonna post this. I'm gonna do the front tower last to give you guys a chance to respond, and let me know what you think. All right, so I got it all assembled. Looking pretty good. I'm waiting for some feedback on whether I'm going to add 5 millimeters up here, but I think we should leave it like that. But I asked you guys, so whoever gets the most votes is gonna win on it. Also, shout out to Ben. Thank you so much for the Napa stickers. I'm gonna put one up on my wall. What's happening, team? So, hey guys, I just got this programmed. We're gonna make 2 of these front towers. I hadn't really took a lot of videos along the way because I got to get these parts out to you, man. So we're working on it. It's coming together. I'll do some machining shots out there. And next is the center brace. Let's do this. All right, guys, I promised to get you some video of that. Of this out here running. I'm gonna try to, So this is what we do, just to verify our tool offsets. Now I do it a little bit faster because I got a good eyeball. You see I missed it right there because I was trying to video. You can see I'm coming down real close to that vice jaw. Now look, what's my distance to go? You always want to check that. Distance to go is 0 because my coordinate is minus 0.155. So we're about to start cutting some material. I got to cut the coolant on. I'm going to take you and let you come with me through it and try not to get coolant all over my phone and myself. All right, I've wiped it down a little bit. I don't think we're going to get much of a shot. No, I'm just going to have to let you guys come through and see it when we're not cutting. All right, guys. So I got to add a tool to this. Program. This is an end mill. This is a 3-flute end mill. Now this is like a drill that cuts sideways. In case you guys haven't seen that or know about it. So I'm gonna I'll try to hold the phone while I gotta hold that button down to release the pull stud, which looks like this. All right, and it's got little balls that go in there and grip that undercut right there. It releases the balls and you grip the undercut. Now what we're gonna do is we're gonna go over here and we're gonna set this tool. And the way we do it, we're gonna set it off a 3-inch block on the back of the vise, because the back of the vise never moves. So the tool offset, which is here, this is the distance. We're going to measure the distance from the home position of the machine, which is usually where the tool changer changes tools, the home position of the machine to the position of the machine when this tip is touching the 3-inch block or whatever you're using to set the tools. Now I can't do this one-handed, but what I'm going to do is well, maybe I can do it one-handed. I'm close enough. Now what I'm going to do is I'm going to use 0.01 per click. And it's going to take a little longer. I normally just ride it up because I'm having to do this one-handed. I should get Luis over here to film this. Now I'm going to go back down 1 click, and the block is going to touch, right? And then I'm going to go into 0.001 per click, and then I'm going to go up a click. Now normally I would just keep going up a click until the block slides, but I got you with me, and I don't have my little head cam. That's what I should have brought out here. Maybe I'll go get it here in a minute. Oh, you see, this would have been the perfect opportunity. So right now I'm within 1,000. So what I'm going to do is I'm going to push this button here, tool offset measure, and it's going to tell the machine that this tool with the tip at 3 inches from the face of this vise is minus 2.525 from machine home. And now I can tell the machine in the program, which I don't know where you guys are at in our How Do I Do That videos. But this is the program, and this is how we tell the machine where to go. Now what we got to do now is I got to go back. This is where we're at right now. We've got it all roughed in. We got it roughed in. Now we're going to start roughing. We're going to take this 1/4 inch end mill and we're going to do some rough work here. And I think we're going to do a couple of counter bores here for our screws. And good morning, guys. Let's do it. I was out there on the machine with my phone, and I said, why don't I go get the hat cam? So I'm going to get on the hat cam, and we're going to go make these front towers for the Talion. It's 3082 Talion front shock tower. We're going to make these out there on the machine, and hopefully I don't crash the machine because y'all watching. Let's do it. All right, guys, we're on the mini mill, and we're restarting the program at tool 3 because it's time to do. I should have grabbed the print. I know what the part looks like, so I didn't even bring a drawing or nothing. We're gonna do some counter bores in here, and we're gonna do the pocket for the M2C logo. Let's check it out. I'm hoping this tool, I might have to put an MO because that tool's probably gonna load up with chips because I gotta drill off counter bore with it. Anyway, I just got done setting it, so that's where we're at. We're at tool 3, and let's do it. It's gonna go up to home. Oh, that's tool 4. Tool 3. Oh, I was wrong. We're gonna come in and we're only gonna do those counter bores in that pocket with tool 4. We're gonna come in here and start finishing the ears with tool 3. I don't know how much of that y'all can see. With my luck, it's focusing out here. We're gonna, but I figured I'd take you guys with me. Let's turn the coolant off. Now watch, it's gonna spit. Now we can see where we're at. Oh, we're already down there. Ah, you gotta have faith, right? All right, so we're at Z-minus 0.140 right now. We're gonna go to Z-minus 0.160. We've been machining at Z-minus 0.150. All right, so what we're doing now is we're finishing the ears. We're gonna come in, and this is 2 parts, by the way. And we're gonna come in. What else are we gonna do with this tool? I just wrote this program yesterday, but you'd think I'd remember. Let's see. Oh, we're gonna come in, I should have roughed that with tool 3, but it ain't gonna hurt nothing. Little teeny cut. Now this is the ears that we're gonna put the, remember earlier in the video, we were talking about using that older style, V5 style front hinge pins that don't screw in. They probably had a bunch of them in stock, so they went back to using them here. I do the same shit, so, oops, gotta cut that out. All right, now we're making counter bores. Now we're gonna come in and clean up that bottom face. Now, why are you going so slow? You can only go so fast with a 1/4 inch end mill. And it's better, let's see where we're at. Turn the coolant off. And it's better to go a little bit slower. Oh yeah, we're looking good. Looking real good. See here, there's our little ears. Our ears are finished there. Looks nice. So I got the coolant off, so what I'm gonna do, I'm gonna slow it down to 25. We're gonna turn the coolant off. All right, so let's blow it off. And we kind of just keep doing this. We look at it and they say, I don't know how good you can see, but I've been doing this for a long time, and it says 0.013. And yeah, I got a little too close there, but yeah, I'm gonna sign off on that as 0.013. All right. So now let's get in there. Let's get this pocket done. Hopefully, you guys can see what I'm seeing. 'Cause I can see what the machine is doing. Now I always got my finger on the button. Hopefully you guys can kind of see what it's doing in there. I don't want to get sprayed with coolant, so I'm not going to open the door and run aluminum and ball up my tools neither. So all we're going to do with tool 4, this is actually tool 4, it's a 1/4 inch end mill we just set. All we're going to do with tool 4 is the pockets where the M2C logo is going to go, lightning pockets, and then we're going to do a little helix bore right there to countersink for the 1/8 inch drill. All right, did we ball up with chips? Ah, you see it worked. What do you know? What do I always say? Even a bad dog gets a bone once in a while. All right, let's make sure that we're coming in right. We're at 0.055, as you can see. We'll cut the coolant off. I'll sign off on that at 0.055. Now let's go. Now we're gonna, what does it say? We're spotting counter bores now. Now we're spotting the counter bores because they got that big old button-headed screw. I sure hope this is coming out and you can see kind of what I'm seeing. But I mean, I can always fast forward through this. I just saw something on Facebook. I just saw something on Facebook that you can drill into your machine. You can cut a hole in this window, and it's got this little doodad that's got like a wiper that spins around at high speed so that you can see into the machine while it's machining, even though the coolant's on. That would be super cool. But then when I looked it up, it was like 600 bucks. And dude, come on, man. I ain't got it like that. So what we're doing now is, now that we're done spotting all that stuff, we're chamfering now. Okay? We're going through and doing all these different chamfers because we got, you can see the commands. Now we're going to do the 160 chamfer. Well, we're gonna have, if you're watching, you can see the comments. At every different operation, I put a little comment in there to tell me what it's doing so that I can know what's going on while we're out here at the machine. All right, so let's take a look. We'll turn our coolant off. All right. There's some FPV machining right here, huh? It's pretty kind of cool. I should have thought of this before. I'm just gonna leave the... So now, we got our little pocket for the M2C right here. We got all these counterboards spotted. Got these counterboards in. Oh, I guess you can't hear them. So, here's our chamfer that goes around the diff. And here's our ears that are finished. And we got these little pockets finished. We got chamfers around it, everything. Well, we're gonna come in and chamfer this stuff on op 3, those angles and stuff. But we pretty much got chamfers on everything now. And starting to take shape. So what are we gonna do now? Oh, we're gonna come in now and we're gonna do the counterboards for those button head screws they're using for those new, so let's bring it in. All right, where are we at? 0.025, I'll sign off on that. Let's do it. So now we're doing our counterbores. We're just doing a little nice little helix right there so we don't build up chips. All right. Now when you're making little teeny moves like that, there ain't no point in going a million inches a minute. Oh, inches per minute is how we tell the tool how fast to cut the material. We do it in inches per minute because we're in the United States. And what we do is we calculate in inches per minute using the RPM. We calculate using chip load, all right? And what the heck, alarm? Way lube. Nah. Anyway, this machine gives us way lube alarms. This machine gives us way lube alarms at random. The way lube's fine, right, Luis? Random way lube alarm on this one.
Yeah,
let's go check.
Back here and hit the plunge. All it is, you come here.
Yeah, pull the plunger up.
And then it won't do it for the rest of the day.
Yeah. Should I get a new way lube pump? Yeah, probably. But it's a calibration thing. That is a new way lube pump as of 2 or 3 years ago when we replaced the spindle. Anyway, here's how you restart a Haas machine. You go to edit, reset. We're gonna go down to tool 6 because I don't think we're gonna spot the 4mm right now. So that's the first time we've used tool 6, or else I'd have to search for it again. We're gonna spot the 4mm holes right now. It's actually going to drop in. It's going to drop into everywhere we got a 4mm hole. Here, 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 here. It's going to drop into those counterbores, and we're going to, and what the spot drill is going to do, you see that? I don't know if you can see that. That's 90 degrees. Okay, and that gives the drill a good starting point and lets it start straight. And it also deburrs the top of the hole. You see how the top of that hole is deburred? Okay, this is going to do the same thing, but for the 4mm holes down here in the bottom of that. All right, so let's do it. Hopefully, I can get you guys all in this. Hopefully, I can get everything before the thing dies. I usually get about 30 minutes. Come on. The reason I keep closing the door to blow it off, I don't want coolant all over me. All right, so 175, I'd call it good. And see, you don't want to cut aluminum without coolant because it'll bog up in your cutting tool. Carbide is sticky. Carbide likes to, or aluminum chips like to stick to carbide because you're creating a lot of heat, and that's why we have to have that coolant, is because we're creating heat. All right, so We're gonna deburr that stuff, or spot drill that stuff. I don't know if you guys could see the horizon of my coffee cup right then. It's early in the morning. Not that early. About 10 o'clock, but I'm just now getting on the machining center. Because you gotta do, there's a lot of other stuff I have to do, and then just, I don't really get to get out here and make parts that much, to be honest with you. Oops. Now you see, we're gonna, that's where our shock tower, that's where our shocks go. So now we're gonna drill all those through holes. All right. That's not too exciting. Hopefully this is exciting for you guys and informative. I mean, you're on my hat, so you're seeing what I'm seeing. This is this is how we make parts. I'll fast forward through this stuff. If I can shut my mouth. How's my battery life? Oh, we're still doing pretty good. We're at 13 minutes. Now, this is on the first part. You don't have to stop and check your tool height every time. You only have to do this on the first part. Hopefully you guys are getting a good view of that. 115, I'll call it good. So now we're engraving our part number. Now we're down there engraving the M2C. And hopefully that that's an 1/8 inch drill mill, which I use for engraving. And hopefully the sides don't hit the sides of that pocket. They didn't on the grass when I did the simulation. So now I'm going to come in. Now I already verified this tool on the other side, so I didn't need to check it again. I see that tool is just on the edge of shattering. That's a 2-inch face mill. So we'll see how it looks, because the material got a lot thinner. All right. So now let's blow it off, see what it looks like. Now, here's the fixture. Michael made this yesterday while I was programming the part. And I came in and put a dot on it this morning. I need to knock that off. Little piece sticking up there. All right. Oh, look how sexy that looks, fellas. All right, so now we're gonna move it over to the fixture. Now, he made this fixture yesterday with this offset. So now this is where we offset our tools. We're telling the tools how far away the tip of the tool is at a 3-inch block from the back of this vise, which never moves. You couldn't do it from the front because the front moves, but the back never moves. All right. So this is how far away the tool tip is, how far away from machine zero we are when the tool tip is touching the 3-inch block, right? That's how we tell it how long the tools are. Now, the next thing we have to tell it is where are these fixtures and these parts at in relation to machine home, which is over in that back corner, which the table moves over this way. Machine home's over here, technically. So what we're going to tell the machine now, we've already told it, but what we need to tell the machine now is where's the corner of this part at, which is where I was programmed from. Okay, and shout out to the guys at Mastercam for making it happen. It's not open out here. I programmed it in my office, but shout out to the Southeastern guys at Mastercam, Trey Spees, and I forget the other guy's name.
for getting Mastercam on the floor. They made me a deal I couldn't pass up with terms that I couldn't pass it up. So now we got Mastercam on the floor, and we'll be programming all our future parts in Mastercam, because I'm not a Gibbs Cam guy. Luis is the Gibbs Cam guy, but we're gonna move to Mastercam, and that's gonna take our shop to the next level. Because I used to just use Mastercam to program just the stuff I was gonna do and screw machines. But now we're gonna be able to move forward and grow bigger. I hope. Depends on you guys, really. Anyway, back to the point I was trying to make. Now, you see this G54, G55, G56. We're not using G57 in this operation, in these operations. What this is see, this is, oh, I guess I was wrong. Machine home is over here, okay? On this particular machine. And G54, which is this corner, the X, which is X, Y, back and forth, Z, up and down, all right? The X of this corner is at minus 14.223 and 4/10 from the home position of this machine, all right? The Y is minus 3.213 from the home position, which is back here. That means the Y is 3.213. It's about right there from the home position. And the Z, now here's what's tricky. You see how all these Z's are different? All right, that's because on off 1, the Z is minus 2.488 from the top of this block to the top of this part is 2.488 on off 1. Now, let's not sing right now. I'm on video, please. Luis thinks he's a singer, but we're gonna make sure he keeps his day job. All right? I don't want my boy starving. So, back to what I was talking about. So now, op 2, you can see is minus about 8 thousandths. All right, minus 2.496 from that surface to the top of the part. That way we can take a cleanup pass. All right. Now, for op 3, we're up on a fixture. Now we machine the fixture at minus 0.005. That means that doesn't make sense. That doesn't make sense, but it gives us a good opportunity to show you how we set that, because I need to check that, because this face is not in line with the top of this block. So why would it be minus 0.005? That doesn't make sense. So what we're gonna do, we're gonna go to an empty tool and we're gonna check that number. I think we got a tool in every single one. Let's go back to T1. Let's go grab an indicator, and I'll show you guys how we set 0. You ain't got an indicator loaded? Luis.
I should have one on our shelf over there. There was 2, one for the meters and one for the...
Okay, so we need to grab an indicator. I don't see one loaded. There it is. There's one. Okay, so this is an indicator, all right? Now, you see the end of this indicator, all right? When that moves, this thing is calibrated, and when that moves, it tells you exactly in thousandths how far you're moving. So what we're gonna do is we're gonna take the tool out. Okay, we're gonna lay this thing right here. We're gonna stick this indicator in there. I don't know if we got enough room. So what we're gonna do is I'm going to go over here and I'm gonna touch this block and I'm gonna set a temporary 0 on the machine. All right. Now, if you look at this, the perfect angle for an indicator is 7 degrees. That's somewhere close, 7 degrees this way. All right, that's where this indicator is designed to measure. It can measure in any position, but I don't know, 7 degrees is supposed to be perfect. Some tool and die guy might call me on that. I don't know. That's what I was told when I was a youngster, and it's been verified by multiple inspectors. So that's what I've always went with. Anyway, now you see how I just zeroed that out? All right. So what I'm going to do is I'm going to prepare the machine to take a measurement, right? So what we're going to do is we're going to go over here to the operator page. And it's basically the same on a Fanuc or whatever. So in our operator page, we're at Z, and we're going to say Z, origin, right? Now it's zeroed, right? So now I'm going to come back up. All right, and then I'm going to come back down and I'm going to touch this thing and I'm going to double check. 0, 0, right? So now what I'm going to do is I'm going to measure from the top of that block to the top of this fixture, okay? Now, I don't have to check if it's flat because it was made yesterday in this vise. So even if it's not sitting on the parallels, which it is, see how the parallels don't move? Even if it wasn't sitting on the parallels, it would still be flat for what we're doing, okay? We'll check it anyway. How about that? Probably what happened is Michael zeroed that thing out so we'd remember to set it. Okay, so we're at 0 there. Now, this is the face of the fixture, and the face of the fixture is minus 2.497 from the top of that block because we're zeroed out here, and that's the reading we got there. So we're going to go to our G56 offset. We're going to go back because I always like to go back to position. Minus 2.497, minus 2.497, and we're going to hit F1 because that's a direct number. All right. So now, what we're going to do now is we're going to go back up to the block. Okay, and make sure that we're still zeroed because things happen. This only takes a few seconds to make sure you're right and that you're not going to wreck your machine. About a half thousandth out, but that's okay for what we're doing. 0, we're about a half thousandth out on the indicator. That's fine for what we're doing. We're not doing anything that a half thou is going to matter on. All right. Keep in mind that a thousandth is 1/4 of the width of a hair. A hair is about 4 thousandths. So we're a half thousandth out. So that should give you a clue of about where we're at on this thing, how close we are. Now, we're going to take this part and we're going to put it on this fixture. And I want the finished thickness of this part to be 0.360, just a little bit over 9 millimeters, okay? Because we're starting from 3/8 stock, and that just gives us just a touch more thickness. So, tool back in here. All right. So what we're going to do is we want this part to finish at 360, and we have our G56 offset set from the top of the block to the face of the fixture. So what are we going to do? We're going to go into our offset, and we're going to say 0.360. And when we hit input, we're just going to add it to it. So our actual offset is Z minus 2.137. All right, and that's going to give us a finished part at 0.360 thickness. So hopefully everything I need is going to be laying here. So I'm not struggling on camera with you guys, but I can fast forward through it. It's no big deal. But what we do have to do is go over here and deburr all these holes on the back of this part. And we don't have a stone out here, Luis.
What?
We don't have a stone for these parts and the vices. We're gonna deburr all these.
Right here. What do you want me to stone the picture?
Stone the fixture, please. And what we're gonna do is we're gonna run a stone on that fixture, and that's gonna verify that there ain't no burrs sticking up. And that'll keep us all flat. And what I'm doing is I'm just deburring all these holes so I ain't got no burrs sticking up. All right, so thank you, sir. Now I'm gonna hit it with my hand just to make sure there ain't no grinding dust on it. So now, so I need to put a mark on this part. I didn't put a mark on the part.
How to load it? How to load it?
I didn't put a mark on the part, so when you go over there, it's gonna leave you an opportunity to get it backwards. In theory, it shouldn't make a difference. It shouldn't mean anything in theory, but theories don't always work.
You don't want the long side.
Let's see, we got 715. Okay, so this is gonna be the short side. It would still be fine, but I would plunge into the material over here. My wife is calling me, guys. Will you screw that part down for me? 8 screws.
Yeah.
My wife is calling me, so that's my beautiful wife, and I'm gonna call her back. I'm gonna put you on pause. Okay, we're back. I made me a cup of coffee. I charged the camera back up, took the front tower off. There's our sample. Luis got this thing screwed down for me, so now let's go run op 3. So, just to recap, we had to set op 3 0, but look how nice the part's looking. It's looking real nice in there. We set op 3 0 and off the block, and now we're ready to run the part. Let's see if I did it right. I'm a pretty good guesser, so we're gonna go down to the next program. So now I think we know that all our tools are set. Okay, what are we doing? C-minus point, oh. So now we're gonna turn the coolant off. So now what we're gonna do is we're gonna cut this thing out. Let's make sure we're in the right spot. We don't want to run into nothing. All right, so what do you guys think? About 180? 215, not too bad. So let's go nice and slow. All right, so that's gonna be right at the fixture. And we're gonna peel this material out. I kind of wish that coolant was hitting the tip of that tool, but it's hitting the tip of the 1/4 inch, and that's our finisher. So we'll be all right. Did you tighten it tight? Never trust anybody to tighten your bolts. Reckon we'll find out right now, won't we?
Yep.
Thank you. I'm trying to get you guys. All right. Yeehaw. Oh yeah. Yeehaw, guys. All right, so what we're doing right now is we're roughing it to +10 with a 1/2 inch end mill. All right, so now we've got our basic shape cut out. We still got some finish work to do. Now, we've already verified that these tools, tool 6 anyway, we've already verified that that tool is doing the right thing. We got to come in here and we got to drill a couple more holes and see we're looking good. We didn't run into nothing. We're doing good. All right, we're coming in and we're doing some lower deburring. I'll show you guys what we're doing right here in a second. And yeah, I did waste a little time because I had to do those tool paths as separate operations because I had to use different approach methods on those different contours. So let's go look at that real quick. Let's get our next tool in there. Because you see I had to use a different approach methods on those. Or else, oh, now my dad's calling. I'm gonna call my dad back. Give me 1 second. Let me catch this call, guys. All right, fellas, we're back recording. I had to take that call. It was my dad. All right, so where are we at? We're fixing to drill some holes. We're looking real good. Now, here's what I was talking about on those campers. The reason I had to come around the thing twice like I did, because you see, coming into this chamfer and coming into this chamfer and coming into this 3D chamfer, you gotta lead in and out of them in all different, all in its own way. Okay, so that's why because it would have been more efficient to say whoop, 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 and then come and do all that at the same time. But it would have been a real pain in the butt to program because it would have considered all these 3D chamfers. Anyway, that's why I went around the part a few times. So let's continue. We're gonna pop some holes. I hadn't seen this drill come in, so we're gonna watch this one come in. We're at Z-minus 0.119. Yeah. I don't know. That's all. I don't know. Doesn't look like 119. R minus 0.135, that's where it's going to peck from. So minus 0.173, so I should just barely be in the part right now. And I am. Alright, so let's pop these holes. And drill like 8 holes, I believe. It'll be interesting to see if you guys can see the bottom of my coffee cup every time I take a drink. And we'll fast forward to a lot of this stuff, I'm sure. Morning, Michael. I couldn't wait. I had to go. Well, I'm filming it too. I can't believe I didn't put the hat cam on before and just come out here and run apart. You know what I mean?
Yeah.
Duh.
All 3 ops are going?
Yeah. 1025. No, it was set right on the last one. Don't look like 125. Came in and cleaned up the intersection of that chamfer. What tool are we on? Now you see, this is our double-sided chamfer tool. We're going to drop in there and we're going to cut around the bottom of that and chamfer the bottom of it. So let's make sure this is coming in right. 0.167.
I don't know where you got this one from. But I thought the change was the right size for the tool.
All right. All right, we're coming around underneath there and deburring that. All right. We won't be able to see anything there, so I'm just going to continue on. And now we're going to come in and finish the outside of this thing. Now you can hear it'll take a little more stock here, a little more stock there. And that's the difference in the cuff of a 1/2 inch end mill and a 1/4 inch end mill that'll go deeper into the radiuses. And it takes out that radius and makes it smaller when it's programmed to a smaller radius. done. We'll pull it off and put it in the car. See how she looks. Then I'll check it out and everything. Oh, you got, where was that cutter at?
Yeah, if it's in the car.
Okay.
Look at that.
We must have plunged. It'll be all right. This is our new S-car cutter. We're gonna try running this as a rougher. It looks like we plunged in. We've been trying it out in a couple different places. The guys over at S-car always take real good care of us. And they have exceptional tools at a good price. And that's all you want, you know? Tools that work. And that's where we're at, fellas. We're looking good. Let's go put it on the car and inspect it. There's my beautiful wife. Look at that M2C girl. You're on camera right now. Did you already go to Gastonia? Yeah. All right. All right, so I'm gonna put you guys on pause again. We're back, guys. We're gonna put this beautiful shock tower on the truck right now. Now, I did inspect it and made sure everything looked good. We always want to make sure that all our holes line up, which they do. So, because what I do, I don't know, did I take you guys with me when I was scanning the part? Because when I scan the part, that stuff's not as accurate as I would like it to be. But when I scan the part, it's accurate. But I always measure it and back those numbers up. I mean, it's always super close. Ooh, that looks good on that red. Let's get some screws in it. Bad example Avery right here. Always start your screws by hand. Remember, I have multiples of everything, so if I strip a screw, it's okay. If you strip a screw, you're probably not gonna be in a good position. Unless you have multiples of everything, but you still don't wanna strip a screw in your dip housing. I'm a cowboy, I tell ya. I sure do hope that I don't have like anything on this lens. I'll be really disappointed if I've got like a big old coolant drop on this lens. So I reckon we'll find out. Let's get, I do like, I might have mentioned this before, look how they put a nut in the back of this thing, guys. That is super cool. I really like that, great idea. I do not like them using button head bolts for anything. I don't like button head bolts. Yeah, they look nice, but they don't have very much material on the outside of the hex, so they're prone to stripping out. I hope I put these on the right side. I'm pretty sure I checked that. There it goes. Pretty sure I checked that, but pretty sure I checked it the last time. Where's my other button head screw? Uh-oh. Look at the mess I got on my table, guys. We're gonna, I need to do a Kevin Talbot, pow! And get this thing cleaned up, huh? Anyway, it'll be fine. Can you guys see? I can see right through that thing, right there. Okay, I guess my whole car's kind of crooked, huh? Anyway, let's get this upper arm and this all put back together. And no, I'm not gonna put the shims in because I don't need them. We're in a laboratory environment here. Look how cool that came out. You see how I left you a little thing to pry those out with? And what I have noticed, guys, is because this microphone is so close to my mouth and my nose, you can hear me breathing. So I don't really breathe that heavy, but it sure sounds like it. So I want to make sure now, you see, we're pretty close right there, but we're not touching. Oh, I wonder if I need to close that in. No, we're good. We're good. Pretty close right there, though. This clearance is clearance. Yeah, we're good. All right, what do you guys think about that? I think it's beautiful. I really like it a lot. All right, so I think I'm gonna go ahead and get this video produced, and we'll maybe section some out for this rear brace, because we're gonna run the parts, and I'd like to get a video out for you guys this weekend. So we're looking good. Thanks for coming along with me. We're on the way, guys.